and welcome to the RS Technical Solutions Tech Talk. I'm your host, Miguel Godino from RS Americas, and today we're going to have a discussion about Phoenix Contact's PLCnext and its innovative features. So joining us virtually today, Ted, why don't you go ahead and introduce yourself and tell us what you do at Phoenix Contact?
Good morning, and thank you very much for the introduction. Yeah, my name is Ted Thayer. I am the product marketing specialist for control for Phoenix Contact, which means any of the products which do control, primarily our ILCs, Nano, PLCnext, are the products I'm responsible for. I've been in the industry for over 25 years now, working for companies such as Mitsubishi, Bosch, Rexroth, and Eaton. My last 7 years have been spent at Phoenix Contact.
Well, thank you for that, Ted. Really excited to have you here. So to kick this off, the PLCnext controller, how would you describe it? And what opportunities did Phoenix Contact see when developing this product?
Yeah, thank you. First of all, I have a couple kind of behind my shoulder here that I'd set up to take a look at.
Okay.
The way I kind of define the PLCnext product is it's essentially a Linux computer shoved inside of a PLC form factor, which means that it can do all the things that a regular PLC can do, run ladder logic hundreds of times a second, thousands of times a second, or we can do extra things, which we'll be talking about more during the show. So it is IIoT ready, and which means it can act as an edge device to Industry 4.0. It can act as a gateway data handling system. So that's kind of what it does. It's kind of the 10,000-foot view. The reason why we developed it was we saw that even several years ago, this whole concept of IIoT and the need for interconnectivity and data handling was going to be a very, very big part of the industry. We saw that was happening, and we saw that your typical approach to automation just wasn't going to continue to cut it in the modern world. Needing to program differently, tapping into a different talent pool than your typical controls engineer. And so even back as early as 2015, we began working on kind of a new ground up controller that could meet the trends of IoT and Industry 4.0, and that's the PLCnext.
Well, thank you for explaining that and giving us a little bit of a background for why Phoenix Contact went on this direction here for the PLCnext. So now with all the new innovations that you were hinting at, how does the PLCnext enable greater flexibility and scalability in the industrial automation industry compared to conventional PLCs?
Okay. First of all, the thing I want to stress is that if you're really just kind of looking for a conventional PLC that is, powerful, we can do that too. You don't need to know anything about operating systems or Python or the REST API. But if you do need that sort of thing, that's kind of what we're about. So a couple of things that come to play into this whole scalability, flexibility concept is number one, because this thing was built on Linux, we are able to take other softwares, programs that were developed on Linux and take them and run them in our system. So kind of an example of that, our mGuard, which hopefully many of your viewers are familiar with our mGuards, our IT security super fortress. It's been around since like 2005, 2006. So we were doing industrial cybersecurity before it was a thing. And we were able to port a lot of what we developed for that, because that's a Linux backbone as well, onto our PLCnext. So we've made a controller that is battle tested already, capable of defending itself in the networking environment we find our world in. Another thing that we've done with our ladder programming is that we've adopted the IEC 61131 standard, which means, amongst other things, you can use very descriptive names. You don't have to call an input X0 or I0, for instance. You can actually call it the start push button and that sort of thing. It also lets you make your own instructions. You don't have to use what we just give you in your ladder. You can actually make your own instructions, which is really cool. Awesome. So that's one of the things that we can do. But another thing, and I'm just going to share my screen here really quick, if you don't mind. We can program in so many different ways if you want to. our traditional ladder logic, structured text style programming, which is free, by the way, our PLCnext Engineer software, is just this little
Okay,
icon
awesome.
right here.
Mm.
Otherwise, if you want to program in Python, or if you want to use Node-RED or C
Mhm.
Sharp or C++, you can do that. You can also use
Perfect.
these together to build very powerful applications. Use the ladder for what makes sense. Use the Python for what makes sense. And what I'm kind of highlighting here is, most PLCs, you get their control engine, the thing that's built in that does the run. With us, you actually can use other options. You can use our hardware, which gives you the limited lifetime warranties, the speed, our IO, but then on top of it, you could choose to run other people's software. Code Assist, which underlies over 400 different companies out there, we can use their software. If you want to use Stratton, which is pretty big in Europe, if you want to use the new universal automation that's being pioneered by Schneider, you can use other different things. So I mean, we are just really, really flexible in the kind of things that we can do. Yeah, one last thing to point out with this concept of openness is the fact that we have a lot of online tools you can use to support yourself. Because we have a product that you can write your own code for, we've had a lot of programmers who have gone and developed special apps that you can download and take advantage of their work. So one of the ones that I'm highlighting here is the PLCnext store. This is kind of like our version of the Apple App Store, for instance, where companies, some of them are us, a lot of them Phoenix Contact, but then there are other companies that they have gone and they have developed either interesting applications that can be used, like collecting data from EM Pros or doing online device management. Imagine pushing a program down to 100 PLCs through a click. We offer things like that. We have add-on libraries to the PLCnext Engineer. We've already figured out how to talk to radio line, for instance, or how to do incremental control. So there's this PLCnext store is just a fun place to spend a lot of time at. And then on top of it, we have the USA GitHub repository for those who are into that. Products that maybe aren't refined enough for the PLCnext store, but offer a good running start to doing some sort of application. We post these up at the store. So like how to do things with cards, how to implement REST APIs through Python.
Mm.
There's a lot of that here. And one thing I just also wanted to show, Node-RED was one of the languages we support. One of the things that's very cool about Node-RED is it's a very collaborative language. Programmers make new instructions and post them, and they invite you to use them, but they also invite you to add and improve. So it's just amazing some of the tools that we can come across with Node-RED. This one here is one that I'd used previously, talking to old Mitsubishi PLCs that don't have a Ethernet port.
Right.
They have a serial protocol called MELSEC that can be developed, and someone actually went and developed Node-RED libraries in order to do that. So we could use this to go ahead and talk to Mitsubishi PLCs. Something that normally could take weeks to write the code was pre-done, and we were communicating in just a couple of hours, taking that data out to the PLCnext, which is actually acting like a black box, and then sending the information up to a cloud for IoT purposes. So, these types of tools that we have online, this type of collaboration just really helps enhance the openness capability of the PLCnext.
Nice, nice.
So beyond that, that's probably the main flexibility we bring to the table, but we
Right.
also bring things like networking security, which I mentioned we are 62443 compliant, which is a big deal in the oncoming world. We also have a built-in HMI. We have a built-in visualization tool that you can write a program inside our PLCnext Engineer software or in someone else's software, like if you're good with Java, and you can actually run that visualization inside our PLC,
Uh,
and then you could display it to whatever, an HMI, to an iPhone, to an iPad, to a computer monitor, but it's all stored inside the PLC, which makes it easy to recover if you need to. And I would say, I think kind of our last big point is the fact that being IIoT ready, we can talk to clouds. So if you need to take data from your application and store it up in a cloud, or maybe say you're a warehousing company and you've got 1 million product SKUs you need to store, but you need to track them, the PLC can run that and talk to that cloud in order to pull down the information that it needs. So it's just amazing how very flexible that we are.
Yeah, really amazing to hear. Let's say the openness of the PLCnext and all the innovative features that make it stand out that more than conventional PLCs, right?
Mhm.
So we talked a little bit on the openness and the IIoT on here for the PLCnext. So could you explain to us the general hardware setup for a PLCnext controller and its software, like the type of I/O boards or I/O modules on them, and how much the software costs, details like that?
Yeah, absolutely. Absolutely. So the first thing that I just want to mention, and I'm just going to go ahead and share my screen again,
Okay, no worries.
if you don't mind. All right.
No worries.
Okay. So as far as what makes up the family, what I thought, picture's worth 1,000 words. So I mean, we'll use that, but then I won't use all 1,000 words.
Got it.
But the controller family as it exists is several different pieces of hardware, starting from the 2152 at the lower end, all the way up to this octo-core monster called the 9102S that has major pass mark benchmark ratings. But where I tend to focus at is going to be more here in the lower end with these types of products, and these are the ones we'll talk about just a little bit. But one thing that ties them all together is this PLCnext Engineer software, which is a free software package. You can download it off the internet and start programming right away. All these different devices are programmed by that. Again, if you want to use it, being open, you could use Code Assist, Python, or what have you, but this is free software. So just to give you a few stats on our current lowest end product, the 2152, it is a dual core chipset. And I won't necessarily read this stuff off. Your viewers can
Right.
take a look at it. But the main thing to note is that it ships with, 0.5 gigabyte of RAM runtime memory, but it is expandable. And we add on modules to the left-hand side. We can do up to 63 I/O modules, and that means we can do up to 4,000 I/O points just on the local PLC. But then through the Ethernet ports, we can do different types of networks like Profinet, Modbus TCP, BACnet, things like that. Profinet tends to be our primary network, but we could do 64 remote I/O stations of up to 4,000 I/Os per station. So, there is a certain tap out. Don't do too much math here, but
Right.
we have seen the fact that a 2152 can control up to 12 to 15,000 I/O points off a single controller. So
Mm. Yeah.
that's a mess of I/O there.
Yeah.
So if you step up to the next one, which is the 3152, that is, I've just kind of highlighted and read the things that are different. So
Mhm.
it's still a dual core chipset, but we are at an Intel. It's got roughly 2 to 4 times the memory, depending what you're talking about. Same local I/O count, but the number of remote I/O stations, we can do 128. So I mean, and the internal I/O table is much bigger. So I mean,
Yeah.
to hit 20, 30,000 I/O points with one of these things is not a problem. And something that's pretty cool, this has 3 Ethernet ports across the bottom, and they each have their own separate NIC card, which means we have 3 differentiated internal networks that this can set on and have 3 different IP addresses and talk to remote IO, talk to your plant level, and another one going out to the cloud, for instance. So, and we've got gigabyte speeds with this thing. So, from there, we've got the 1502 and 1522. These are the last two I'll kind of talk about here. They're
Mhm.
basically the 3152 on a small IPC type device that's not much bigger than a couple of your cell phones kind of tapped together. And so this gives us access to wireless networks, additional serial ports, USB ports, and then just generally a lot more memory, up to 128 gigabytes of local memory to do with what you need. And we kind of call these edge devices because they've got things built in like Docker, which Docker's pretty cool. It's like a virtual machine. You could take a program that wasn't written for PLCnext, but maybe written for a Raspberry Pi, and you could put in the Docker package, drop it in our controller, and just start running it without doing a whole bunch of rewriting. So we've got a lot of interesting IoT quick connect options available with this. There is no local I/O. You only do remote I/O, but you can do quite a bit with
Yeah.
that. So the other thing I wanted to mention from a hardware perspective is that we can use a number of different I/O types with our controller. So, you've got the Axial line left, which is our very dense, very high quality, highly configurable I/O that we've got all these different types of, high speed, strain gauge, analog, thermocouple, et cetera, et cetera. But then we also have what we like to call the more cost-effective axial line smart element I/O. These are like small modules. These are little bases that they kind of plug in together. And each one of these is an I/O module. So like this thing right here is a little base that's got 6 I/O modules. It takes up about the same space as 2 of these here, but because it's much more compact, we could fit up to 96 I/O points in there, depending on what kind of I/O we're talking about. So you've got the highly configurable, you've got the compact value, and they can be used together. You can mix them into the same system, which is really cool. So then longtime Phoenix fans may be aware of the inline PLCs because they've been around for decades now. And so there's a very wide installed base of the inline I/O. And so we make it so you don't have to toss that out if you want to do the next generation programming. We make an adapter and you can use the inline I/O that you've already got with the PLCnext controller. So very cool. Now, if you do that, that's the only I/O you can use. You can't mix and match like you can with other things, but you can still use the I/O if you want to.
Well, amazing to hear all the modularity that comes with the PLCnext and the I/O capabilities. Now, if you had to tell our viewers what type of application or situation, what do you think the PLCnext would be great to be used in? Any real world cases that you'd want to mention?
Yeah, I have. If we have time, I had 3 stories I could share that kind of highlight different aspects of what makes it so amazing, I think. So, one of them, I have to omit names because of NDAs and discretion, but I can tell you that there is a national pizza chain, that runs stores, and they've developed a pizza oven built around PLCnext. And what makes it interesting is that it does 10 axes of motion. So, we're not a motion control company, but we have no issues with running motion control algorithms if somebody writes them. And so they did 10 axes of motion to make the pizza and do the cheese and all of that. But then the recipes for the pizzas are stored up in a cloud. And so when they enter the order for the pizza, it goes up to the cloud, accesses the recipe, disperses all the ingredients, and then cooks it. And so that way you kind of take the employee out of the equation a little bit, whether it's the first pizza of the day or the last one of the day, they're exhausted or they're brand new. You kind of take them out of the equation, and you automate the pizza process, if I can use that term. And so if they decide that they want to tweak the recipe a little bit, maybe to add a little more cheese and see if there's a follow-up with customer satisfaction, they just update it in one place. If they want to make a new version of Hawaiian pizza, they could just put the recipe in there, update it in one place, and then every store has access to that. So it's a cool application. It brings in the networking. They are using a combination of higher level languages such as Python to do the network communications and standard ladder in order to affect this control. So that's kind of a neat one. Another one that I kind of like is a company called Radom. I could mention them, Radom Corporation. They're up out in Wisconsin. And what they are doing is trying to make the world greener by taking animal waste products and then converting it into fertilizer, which then they can use a high grade fertilizer that the farmer can use that to, fertilize the fields in a natural green way and to take stuff which would normally just be a waste byproduct and make it useful. And so we like that because it's green. But the interesting thing about it is this is one which is entirely, the program was done entirely in C code. The IO control is minimal, just turning on a few things here and there. But they wrote the whole program in C because there's just a lot of algorithms, a lot of data you got to process in order
Right.
to make this process work efficiently. They did it in C code and could run it on our controller. So then kind of the last one that I was going to mention is kind of an interesting one. There's a company called Electrical Controls. They're out of Ohio. They call it automated chicken coops, but these don't look like coops. They're more like condos,
Mhm.
very large systems with hundreds and thousands of chickens doing egg laying, and they control everything from feed to the climate, the humidity, the temperature, and that sort of thing, lighting, and they do it all with automation. Well, what makes this one pretty interesting in my mind is originally they were using a Codesys-based PLC from another company, but during the COVID supply chain issues, they could not get that controller, and they were like, "Man, we've got contracts to fulfill," and so they reached out to us because they heard we had the proper IO and that we could take a Codesys program and run it, and we could. They didn't have to rework their ladder. Codesys also has a built-in internal HMI. They didn't have to remake any of that stuff. They actually dropped it in our hardware and started running it. And because they liked our support, liked our limited lifetime warranties that we offer, they've decided to stick with us. So this was an application that we won because we could run someone else's software on our PLC, and then we brought certain advantages to them. So I think these are our three real world applications that are very interesting, kind of show our range.
Yeah. Well, thank you for explaining how the PLCnext is used in real world application. I really like the pizza one, made me a little hungry, but
Yeah.
let's go ahead and move on to the next question, right? So, is there any future advancements or enhancements that we could expect to see on the PLCnext in the near future?
Oh, yes. There's a handful I'm comfortable sharing with your viewers.
Mm. Okay.
Of course, there's always software changes going on, new instructions, new symbols for the visualization library, things like that. But some of the ones that I think that your viewers might kind of find interesting. Um, I mentioned the EPCs previously, the PLCnext on a little IPC. We're going to be releasing something called the UPC, which
Mm.
is on a much more powerful IPC. So it's the PLCnext incorporated on something with quad control, lots more memory, more ports, that sort of thing. That's going to be an exciting one. Another one that we'll be releasing, some of your viewers may have heard of TSN networking,
Okay.
the ability to keep remote axes synced up to the same clock, becoming critical in a lot of different applications, especially if you're doing remote control where the PLC actually might be somewhere else, up in a cloud, for instance. We support that already. We've released that for our BPC 9102S, which I mentioned in a previous slide, but didn't go into a whole lot of detail. But we're going to be rolling out TSN networking to the other
Nice.
PLCnext products. Another one is the virtualized PLCnext. I call it the portable PLCnext. So, that runtime engine, we've taken that and kind of turned it into a container. So that way you don't just have to run it on our PLC hardware. You could maybe put it on uh, someone else's IPC, or maybe run it on an HMI, or run it on a Raspberry Pi, or maybe even embed it in an Ethernet switch. So we've kind of
Right.
taken the intelligence and have made it portable so that you can run it in other different environments. So something I'm very excited about coming out.
Yeah.
And then lastly, we are going to be releasing a product called the 1252. So
Okay.
it is going to be the new low end below the 2152.
Mm.
So this is going to be a lower cost product that still has all the same features, higher level languages, that sort of thing. But maybe the price point is more accessible if say you're a company that built a PC-based board that you did your control, and you're like, man, I want something more off the shelf, but an
Right.
actual PLC is like, the cost, or maybe you were
Yeah.
exploring stuff with a Raspberry Pi and really need something more durable. But again, you want to be careful about your cost. This is going to be
Right.
kind of a new lower end controller that could help with that. And then the other thing that we are doing is I mentioned our IO, which is on the right hand side of the PLC. We also have the ability to add stuff on the left hand side, and we
Okay.
call those extension modules. And so we have some that are out already, such as an additional Ethernet module you could plug in on the left side, and that gives you an additional NIC card, an additional Ethernet port to do stuff with. We've got an add-on that can do safety, that turns the PLC into an actual full-fledged safety controller for, you know, grand total safety controller, coprocessor, and the PLC for like $1,400. This is going to be a source of more and more functionality. We released a new power monitoring module, or we'll be releasing one soon. We released one called the kit module, which actually lets you make your own add-on piece of hardware. Man, I really want to do a cellular modem. You can use
Yeah.
the kit module and add that on. So you're going to be seeing a lot of new development there,
Nice.
as
Yeah.
well as some legacy stuff. Do you still need to do Profibus, Interbus? There's a lot of installed base for that. We can handle that as well. So that's just some of the new things coming out to keep an eye out for.
All right. Well, I'm really excited to hear all about the new stuff that's coming out from the PLCnext and all the possible things that Phoenix Contact is working on, and looking forward to seeing it. Well,
Yeah,
Ted,
me too.
yeah. Well, Ted, that takes care of all the questions I had for you. But before we go ahead and sign off, for the people considering adopting the PLCnext controller, where would you recommend for them to help get started and maximizing the benefits of this platform?
Been putting together a single sourced web page that brings together all the different pages, including some of the pages that I showed earlier,
Mm.
and that is www.phoenixcontact.com/us hyphen PLC Next hyphen technology.
Mm.
We'll make sure that we post that out somewhere. But
Yeah.
but that
Yeah.
is a single page that's got all of the controllers, some of the self-training that we've been developing with other companies, online training you can do, some training manuals I've put together, all the different websites for doing tech support and downloading functions and function blocks and stuff. It's all together on that one page, and I'll continue to be adding to that as we release more brochures, use cases, that sort of thing. So that
Nice.
that is really the best website to start with for just about everything.
Gotcha. Well, thank you for that, Ted. Is there any final thoughts that you would like to say?
Um, you know what? I think you covered it pretty good with the questions you asked. I do appreciate your time
Yeah.
today, and yeah, I would encourage if you're someone watching this podcast and are interested, feel free to reach out to RS America, or we have a full several engineers in the field, what we call CSIEs and ASEs,
Mm.
all over the country that have advanced technical knowledge and will be there to and ready to help you.
Nice, nice. Well, I really want to go ahead and thank you for your time here, Ted. I appreciate you going over the PLCnext and all the cool IIoT and openness features that come with it. And to our viewers, remember to go ahead and check out RS and Phoenix Contact for your future IoT applications or automation applications. And we'll go ahead and catch you next time on the RS Technical Solutions Tech Talk. Thank you.